Okay. So we had great talks already about AdS, CFT, and I don't want to repeat anything here, so hopefully I won't. But I want to move a little bit the framework, to move this discussion into a different framework. So in trying to define my framework, I would say it's a philosophy of science perspective on these discussions that is probably needed. In a continuation of discussion on emergence and supervenance, I'll try to kind of give a different perspective, and obviously philosophers do like that, to look into this from a different perspective. And in my case, this perspective is, broadly speaking, an inter-theoretical relation between models. And of course, as you see in the title, I will look into the unification case. And I will repeat some things. I have slides, I have a list of slides that I can skip, but I will repeat things, so I'm sorry, but many things will be, I will rephrase them. So that's one of my aim, to look into this into the context of unification. And probably this comes as a continuation of the discussion you had. When you are skeptical about emergence and about fundamentality, unification can be an alternative. It's not the only one, but it's an alternative to this skepticism or cynical position we want against emergence. So it's an alternative. So we like alternatives, pluralism. Okay, and probably you said that, Amanda said, it's interesting how it's very enticing philosophically to connect different dualities and look at dualities and string theory to other parts of physics, other disciplines. And we know that from philosophy of physics, philosophy of science, that theories which are better related to other theories are more robust to many things. You don't want an isolated theory, a theory of everything if you want, but not related to anything. That's something we want to avoid. So in that sense, that's important to connect this, to interpret AdS CFT into this context of inter-theoretical relations. I skipped that, but I had some reasons and one argument actually to look into this as a intermodal theory, as models, instead of inter-theoretical as in relation between theories. So in any case, this an external reason, connect them to other theories, internal reasons. One reason that you may be interested are their principles of quantum gravity. So, because many other theories are formulated in terms of principles, so you look internally into the theory and look at four principles, right? So the compare and contrast class here is obviously the discussion on emergence and the fundamentality. Now I want to be clear here. I don't want to say that unification does not imply fundamentality, but emergence and fundamentality are related, and unification gives a different perspective on fundamentality than emergence. That's all I want to say for the time being. And one other part of the project, and hopefully we'll get there, is to connect unification to explanation. So explanation is something you want to hear about scientific theories and you want to hear about models. And probably we want to look into explanations, and it's a kind of standard perspective in philosophy of science. So yeah, that's what I'm trying to do. Now, we talked a little bit about this. So I will move this discussion into the literature written by philosophers of science or philosopher of physics who wrote on this, without ignoring, obviously, the huge literature in physics. But I just wanted to give you some of them. And I think that Haro was mentioned. Castellani is one of the first, David, and papers by Rickles, and Nicholas Tech, right? So there are many. It's a critical mass already. So some of the preferred topics of discussion of this duality issue, and probably this is in Rickles clearly expressed, it's emergence. Then they talk, many of them, I don't, but Rickles and David, for example, talk about underdetermination, and we did that too, and obviously metaphysics and ontological issues. Structural realism, that's in Rickles, obviously. That's an important piece that I want to discuss, and also the ontology. Now, the ontology is related to fundamentality, the metaphysical aspect of this underdetermination is important. Okay, the last one is the one that I'm interested here. So unification and pluralism of this. Again, of course, you can ask me what unification is. So instead of just defining it, I will try to delineate it and give you the exemplar cases, the best cases we have. And obviously, I will not claim ever that we have any kind of exemplar cases of unification, but it's enough to put them on the map and then situate my case here somewhere on the map in the case of unification. Okay, so I think the AdS CFT duality illustrates the holographic principle. Pretty uncontroversial, is an important chapter in the history of string theory and quantum gravity. And we may all agree that at early stages of the development of the theory, there are philosophical discussions. Now, I may take this back. It depends what we mean by early, if this is an early stage or not. But it's probably not that early anymore. But let's extend early to childhood and the teenage time, right? In any case, early, not so early. Right? But remember, in some cases, if you look at history of science, philosophical discussion came back to and haunted even much later theories. So that's not necessarily this relation. Okay, so other reason to look into it, I think it's open to interpretation, this duality and many other dualities. Interpretation being obviously a philosophical work, and I hope we can look at it beyond calculations and, like you mentioned, this kind of, what was not Feynman, but Gross, right?
Yeah.
Just shut up and calculate,
yeah.
something like that. So we want that. It's not that I dismiss calculation, that's probably the most important of all, but you should do something else than that in addressing this. Thank you. So that's probably... Philosophers do look at these situations in which there is a longitudinal and cross-sectional relation between theories. Theories which are contemporary and theories which are different generations of theories. So we do that pretty frequently. So obviously we can do that with string theory and within parts of the string theory. So when I said there are exemplar cases of unification, so this is almost like obvious to everybody. We'll talk about 2 or 3 of them. And I don't want to say that this is an exemplar case, it's a new case, and probably illustrates something that wasn't present in the history of science in general. I don't say it's exemplar one. I will discuss 2 interpretations of unification here. Probably you can say, wait, it's not interpretation, it's like a meta-interpretation, second-order interpretation on what these are supposed to be. One is a spurious case of unification, and the other one is not so spurious. Yeah, so obviously you can say, you gave us 2 of them, but how do we choose between the 2? So obviously I don't have an answer to that, but at least let's talk about some of them. All right. Okay, we'll skip some of them. So here are some questions that a skeptical note. All the questions in quantum gravity are already addressing the previous discussions in philosophy of physics, and so on. We agree about that. Reasons to do that, to do this, and obviously after you answer no, is differentiate big pictures from small picture, clarify the philosophy within history. Everybody has a history, right? String theory has a history, everybody has. Dualities do have history. So you can do philosophy piggybacking on the history all the time. We do some interpretative work based on what interpretation we give to these pieces of theories or models. And you can be also normative, right? So this kind of normative questions in philosophy of physics or philosophy of science. What you should do from now on, what you didn't do the right way in the past or present. That's the normative part. And many other things that you are probably interested in: theory choice, theory assessment, theory validation. So, well, some fun quotes from Red Hat about the relation between physicists and philosophers. But we kind of discussed already this. You cannot see it. Is that visible?
It's good.
Yeah. So physicists without philosophers are like not infants, but young children riding the bike without knowing the subtleties of the physical dynamics. So it's like it's not examining life, but life here is the life of the scientist. You do stuff without examining what you do, right? So very philosophical note. Look at what you do when you ride your bike. This means when you do physics or any science. I'm going to skip this because almost everybody knows about this, but I think Harvey in the previous meeting, okay, he mentioned these stages of the development of string theory. Of course, the way you divide history is always the history of anything debatable, right? But he believed, is that right? You said you saw his talks.
Yeah.
Yeah, he divided it this way. So one way to, what I'm trying to do is to look actually into the relic or the fossil record of dualities from the previous stage, right? Because this happened in 95, 90-ish, 98, the AdS CFT.
AdS CFT was November 97.
97, okay, so November, okay. And this is previous decade, yeah? So, okay, so the fossil record of unification into dualities. So that's, obviously, is a pejorative way. Probably you should delete M theory if you don't believe in it, but we are definitely in some duality stage of the development of string theory here, according to Harvey and others. All right. So what you see now, 2000 plus, probably we should try 2010 plus. The fragmented picture, you see more emergence discussion than reduction. By the way, I think we kind of forget to discuss a little bit about reduction because reduction is a strong point in which you reduce a theory to the other, right? It's a strong Nagelian reduction. And that's something you definitely thought about in the original formulation of the string theory and other quantum gravity problems. You don't see that anymore. But you see this unification, disunity rather than unification, pluralism replacing fundamentality, and many people will give up any kind of view about the theory of everything. Okay. So many people would say you shouldn't do this, but we are here, therefore we do it. So wait and see with this is Butterfield point. You remember he said about this tragedy. So philosophers should be like the Greek tragedy chorus. You have to wait till everybody dies, everybody commits suicide, all is done, and then the chorus comes and up the final part.
I think Jeremy was saying that you should not be.
Yes, he said you should not, but this is the part in which you say, who would do that? So, but this is, no, Jeremy mentioned this. He said you shouldn't do that, obviously, but there are people who would say we should wait till everybody's shot. They chop their heads and see. So the Greek tragedy is over, then the philosophers comes in are alone on the stage, and they mention what happened in the other person. So okay, all right. So now I had a little bit of discussion yesterday about these examples of dualities. Now you may not like some of them. You may say this is not duality, but let's get into some. So this Polschinsky paper. Recent paper, he talks about some of them. I don't want to repeat myself, but some are, like unification, these are very nuanced dualities. There are different dualities, they are not the same. So the second one, okay, the classical electromagnetic duality can be expressed in the terms that when you flip E with B and minus E with B, the classical electromagnetic equations look the same, right? So you have two dual models of it, and both of them are equally real. So that's the classical one. There are other electromagnetic dualities in which you don't do that. You just, the original one is without sources. Now you have to think about dualities with sources. And on the top of the charges, you need to add monopoles, magnetic monopoles. And Dirac said, if you do that, then you have to kind of think about they are real because electric charges are. So you have some form of scientific realism. If you believe in dualities and the duality will force you to say something about something you don't observe, then you kind of postulate, right? So the result of Dirac from that kind of duality was that he explained in probably 5 lines the quantization of charge, right? That's an explanation. I mentioned that explanation is important. So you have an explanation of a fact which is present in one theory, but it's explained kind of through the postulation of duality. Do you see this? It's not obvious, but this is kind of the Dirac standard interpretation. So you explain the quantization of charge, which is real, you measure it, you don't know how to explain it. There are other competing explanations. The Kaluza-Klein, right? The Kaluza-Klein explains quantization of charge too. We are talking about the 1930s. And so you have some implication, scientific realist implication of dualities there. It's interesting. In the second case, you have two descriptions that complement each other, and one of them are both of them are classical limits of the same theory. Fundamentality. In that case, you don't say one is more fundamental than the other, but you say both are, if you want, second-order fundamentality, and more fundamental is the theory from which they come, the quantum field theory. Now with the T-dualities, no, we didn't talk too much about that, but in the case of the T-dualities in string theory and the S-duality, you infer parts of, so you discuss about fundamentality of space-time, I suppose with the first one. Let's see if I have, yeah. You question the fundamentality of space-time and probably the type of space-time you are familiar with by the T-duality. With the S-duality, so here is, with the S-duality, you question the fundamentality of strings, as defined, right? So you can start to think about who is which, no, what is more fundamental, the D-branes, or the strings, or none, or if you have the coupling constant equals to 1, it's kind of democracy there or something.
Yeah, so they call it P-brain democracy.
Democracy, that's Townsend, right?
Yes, Paul Townsend.
Townsend, yeah. So the democracy means there is this coupling constant where everybody's equally fundamental, equally not fundamental, right? So yeah, well, that's useful. I didn't want, but that's kind of the type of question you ask. This is a quote from Zwieback. Yeah, Zwieback. And he's probably mentioning this important thing. You can replace for philosophical usage description with representations here. That's what he means. You have two representations of the same physics within duality. Now, other ways to interpret dualities is to think about them as redundancies, gauge redundancies. You can think about them as definitions. So this is good for AdS CFT, but we haven't talked about that too much. But you can actually say the duality is a definition of string theory, right? In the sense that it defines string theory through the duality. So you can use duality for definitions. Well, remember, definition is something that it's more conventional and it's used, but can be changed any time. And it's a definition, right? So from the philosophy of language point of view, you are not committed to the existence of anything that you define. That can be used too. Do I have how much time?
So you have till 25?
Oh, it's more than we should start late.
That includes questions, right?
Yes.
Any questions?
Yes. Okay. So, what time do I have for my talk? Like 10, 15.
Yeah,
Okay. Thank you. So, okay. So this is the slide I was looking for. So T-dualities expose the ambiguities of space-time, the topology, the momentum, the winding symmetry, and stuff like that. As duality between the ambiguities between classical and semi-classical. So when you say ambiguities, I think we refer to we have a language, and ambiguity means it's not precise enough, and we need to correct it. So in that sense, they expose something that is already in the theory or the model. Okay, so now is this a good idea or not? That's the question. Are dualities inter-theoretical relation? And obviously, my correction will be inter-model relation or not. If there are relations between very different theories. And when you say very different theories, we don't refer strictly to their formulation, but we refer to their structure, and which is more objective and if you want more important, and that's the space-time structure or symmetries and stuff like that. So you want to think in terms of intertheoretical relations that there are actually different. Now, back to unification, and for that I don't have a slide. I don't have slides. But when you talk about unification, you like to think about this kind of exemplar cases of unification. One of them is Newton's unification of celestial mechanics with terrestrial mechanics. And the way it worked, historically, hopefully I'm right here, is that he did identify some things. He identified the type of motion of the moon, or the celestial object, with the type of motion of the cannonballs, right? Normal bodies. And also he said, if there is a kind of Aristotelian time of the eternal bodies, is the same as the time of the terrestrial bodies. So the time is the same. You don't have t there and t here. You have equivalent, perfect identity of the two times. The time is the same. The time of the moon and the time on the Earth, the space on moon is the same. So you see the identification. With the Maxwell unification, you need to identify the ether, luminiferous ether, with probably the optical ether, right? And then you identify it with the magnetic ether. And then you get the unification. You get speed of light. You get the electromagnetic waves, which weren't in the original theory. So you need some identification. And in that sense, these are the exemplar cases. Nobody would say these two cases are not good enough. And then you can look at electroweak unification. Special relativity is a kind of unification too. I don't want to get into the details. General relativity probabilities. Kaluza-Klein example, 1926, that kind of Kaluza-Klein, it's a unification. So, and then you can you can rerun all my questions about the explanation on all these cases, and you find some explanations everywhere, right? Probably the easy case is the electromagnetic wave. It's good enough. It's an explanation of the electromagnetic wave for Maxwell's case. Okay. So now with the AdS CFT, so would we expect this or not? So here is one. There are some quotes here of string theory saying it's not something you would expect to happen. So on one side of the AdS CFT you have. All right. So on one side of the AdS CFT you do have a gauge theory, which is a conformal field theory, which is a Young-Mills theory. Okay, so that's the right-hand side. I started with that one. On the other hand, you have a string theory, which has a limit at AdS space. Originally, it was only AdS 5, but then it was extended to AdS 10. AdS 5 times M5, which is a 10 space. So that's an extension you need to do. So you don't expect that. Why? Well, there is a huge discussion why there is a mismatch in the gauge theory and the gravitational theory. People would say, no, they are the same, but there are many arguments saying they are fundamentally different. They don't kind of match so well. Okay, it's not yet.
Just a quick question though. I mean, we know that the ground state of a closed string is the graviton.
Yeah.
And that the ground state of an open string is a spin-1 gauge boson. So it's not all that surprising in some ways that that came about. That's why when I talked about the origin of the correspondence, people took it much further after that, right? But how it came about was taking
Yes, but let's think about the extension to 10 dimensions, right? If you extend it to 10 dimensions...
That was how the correspondence was originally described.
Yes, that's right.
It's not an extension. So, it was derived as such, as AdS 5 times S5.
So the original correspondence is not so serendipitous or not so novel, but when you extend it to 10 dimensions, you don't have a gauge super Young-Mills theory in 10 dimensions.
It lives on the theory on the branes, which is a 3 plus 1 dimensional system. So the theory on the branes is n equals 4, 4-dimensional super Young-Mills theory, which has so many extra matter fields than the gauge boson that it's conformally invariant.
So it's not so surprising somehow.
Well, I think it is surprising and beautiful. I'm just saying there was a reason why it was sniffed out. You know, why people found it, and it was staring at D-branes.
I read a little bit of this historical argument. Why? Actually, because string theory originated from partial model. It's kind of a good historical argument why it actually contained this gauge theory inside. It's kind of coming back to home. It's like a boomerang hit, right? Came back home. But but when you extend it to the 10 dimensions, right? That's the surprising part. You wouldn't expect that to, but you said that you actually talk only about the boundary on the 10 dimensions, right?
Well, when you're doing the 10-dimensional physics, you've got a bulk that it's got a sphere that's a compact manifold. And so the non-compact physics is in a de Sitter space. But one of the ways you know it's there is that the 5-sphere has a symmetry of SO6. That is represented in the conformal field theory as a symmetry, what's called R symmetry in the supersymmetric field theory.
Yeah, that's right. But without that compactification, you wouldn't expect a super conformal field theory in 10 dimensions. Right?
Yeah, you get a superconformal field theory in 3 + 1 dimensions. Right. You get the full AdS times S bulk string theory in the 10 dimensions. Okay. So, yeah, well, as you see, surprising is subjective, right? Surprising or not being surprised by something you thought you saw. Yeah, so, but I saw this in different places in the literature, that is kind of surprising. It was revolutionary. I'm saying there's a reason why he derived it, but it was revolutionary. One of the most important ideas in theoretical physics in the last quarter of a century, I'd say.
Yes, so, yeah, I agree, yeah. But,
astounding.
Yeah. So now, going back to my spurious, I put the word spurious there. Now here is one way of thinking it about the spurious part. So I will really skip this because we kind of discussed this and you kind of told us already. So what are the 2 parts of it? But the spurious part that I want to clarify here is something like this. What is a spurious unification? Spurious unification is something that comes as a unification but is in fact a consequence, deductive consequence of what assumptions you already put there, willingly or unwillingly in the theory, in the 2 parts of it. So I think the most, if you want, immediate reaction to what I just said is to say there is something already in the 2 theories, like we discussed, that you already put there willingly or unwillingly, and that's what explains the unification. Now, going back to my exemplar cases, that's not the case with any of the exemplar cases we discussed, right? So you can defend Newton didn't do that, and Maxwell, or probably, well, there are other cases, but, so what is the common part that is identified? It's the same in the 2. So obviously the first reaction is to think that supersymmetry is there, yeah? So unification, question mark, yes, if supersymmetry it comes out as unified. So I have a nice if you want, 3 words in Latin, X supersymmetry quadlibet sequator. That means, you know what that means, right? Or from symmetry anything, so from supersymmetry anything comes. But this is used usually for the first year logic, saying from falsity anything comes out, right? Anything can be inferred from false premises, right? You know, so. But I want to absolutely immediately resist that. That's not the case. So it's not a spurious unification because supersymmetry is there. So one reason why it's not is that there are cases much more complicated and I don't understand them, in which you kind of, so N4, this is the supersymmetry. This is the highest degree of supersymmetry put in the AdS CFT, right? That's what it was needed.
Yeah, because N = 4, D = 4, which means 16 supersymmetries.
16, the highest number possible that you can put. And then you want to go lower, if you can, to N = 1, as far as I understand.
And people have actually even gone to N = 0.
N = 0. That's the good news.
Conjectured.
Yeah,
right.
And you still have, so in that case, with N = 1, you still have the unification aspect that I'm talking about. So supersymmetry is not that kind of assumption that you introduced. So that's,
well, if the theory were not supersymmetric, by the way, for the original ideas 5 times S5, it wouldn't have been a conformal field theory. It wouldn't have been enough matter to make the beta function 0.
Yes.
The gauge particles contribute to...
It won't work.
Right.
But what I want to say is that, besides all the fact that it doesn't work, if it's a unification, the question is a unification because of it or not? So that's kind of a question I'm trying to ask. Okay, address. So, okay, I'm going to skip. Okay, so in this case, I have 4 or 3 types of philosophy of AdS CFT that you can discuss. And just mentioning a little bit of points of view that we discussed before, I want to insist on that one. So remember, I just don't want to discuss emergence of space-time here. I kind of go around this topic to you know, reach my purpose here. But we have to talk about the meaning of the meaning of the terms that are in the AdS and the CFT. So the Haro believes that there are 2 ways of thinking about it. So one way is to think that there are actually more than 2. But let's talk about one way is to think that all the terms are the same in the 2 parts. Anything that you phi 0, phi 0, that's the field, and R and space and time alone and space-time together and energy, all these are the same, have the same meaning, right? That's one way of thinking. The other is to think that some things are equal, they have the same meaning, but in fact some very important things are different. They don't mean the same thing, right? That's the second. And the third thing, third way of doing that is to say the meaning of the terms are kind of free in the 2 parts, but they kind of get their meaning from a third something, which is a super other structure, and that fixes the meaning of this. Right? Okay, so in the case of unification, you do that. So when you unify, you go back and say, hey, this was wrong, this was right. In terrestrial and celestial mechanics, you correct them. You don't just say trivially, you take bulk from the full and the full theory 1, full theory 2, they unify their meanings and they are right. But you go back and fix meanings, right? And you eliminate meanings. So you don't want that, you don't want that. You can think about biology, the great synthesis in biology. You have genetics, you have evolution, and you go back and say, hey, these parts of evolution is wrong, this part of genetics is wrong, and you correct them in some kind of synthetic way, right? So that's a lesson in philosophy. So in that sense, it is a unification, and I want to wrap up, is not, okay, this is about the definition. Definition is a trivial case in which you say, there is no third thing. There is nothing like a third theory. But from the CFT, you take CFT seriously, and this theory will fix the meaning of the string theory. Just take this theory as serious and then go. It's not like 2 natural language. I want to be clear. It's not 2 natural language. You don't fix meanings in English from French or French from German. You don't do that. This is the strong in which you have the language of a kid of 5 years and you have these adult guys. And Santa Claus, okay, so you translate the Santa Claus of my son, which is 2, into this kind of like a guy who's paid to be in the mall and put his hat on, his fat old, right? So you translate it. You don't do the other way. You don't translate what I know about Santa Claus and what my son knows, right? So in that sense, it's the translation problem. But the unification, we say, no, you don't translate CFT from AdS. You go to a third structure, and probably, because we run out of time, okay, this is the discussion we already have. Many philosophers are skeptical about emergence, Rickles, many other people. But my talk is not affected by that. You don't need, once you are skeptical about that or cynical about emergence, you are okay with what I just said. It's fine. You can be super uber optimistic about M theory, but I'm not taking that path either, right? I'm not talking about the M theory. You have one option. Okay, so this is kind of the structure of arguments in which you say this emergence is a weak emergence. There are other cases. So somebody mentioned Verlinde, the Haro talked about. So Verlinde says, well, between this weak and strong, there is like a third way in which you have emergence in the Verlinde schema, right? So there are kind of degrees of emergence. Okay, so that's probably very decent. So finally, I think this new unification is a case in which, okay, I will skip. Yeah, so don't think this is an exemplar case. Those are in the history. They belong to the history of science, and that's fine. But in this case, what we want to do with this kind of unification is to explain the duality through a unificatory schema. And like I said, one way is to do this through meanings. And this is the important part. Meanings of terms are important to fix them in different ways. And you can look at these exemplar cases as exemplars, like saints, but you are not going to get to that moral perfection here, but not yet. If you are very optimistic about M theory, then you can say, hey, that will work exactly like unification of terrestrial and celestial mechanics of the three laws of Newton, right? But obviously that's not the case. And probably I will just wrap up here. Thank you.
Yeah, I just have a specific question regarding the broader sort of philosophical concept of duality. If I remember correctly, you have given this general characterization on one of your slides of duality that it involves two different descriptions of two different physical systems in one theory, and then later on you added this equation that duality may equal redundancy. And I kind of like, I see a tension between these two.
Yeah.
I don't see any redundancy in the fact that you have two different systems described in different ways. I mean, what's the type of redundancy would be? Right?
Yes. These, what is a duality, are completely exclusive and exhaustive, not exhaustive, but exclusive definitions. One of them won't work with the other one. So once you believe in those, the fourth one, not the third one, right?
Oh, so these are
different.
alternatives.
Yes, alternatives.
Oh, okay,
yes,
okay.
yes.
All right,
So
okay.
I didn't mention this, but this is the situation in which you hope that the dualities will disappear in the future, right? They are going away. The other one is definition. You say, hey, it's a convention. You keep it because it's a definition. These are exclusive, and of course, which one is the one that we kind of used here? Probably is the first one, because, well, you can use all of them, but these are from the literature. Probably each of them is, for my purpose, probably the first one works better, not the second, and not the third, because if you start to define things, then you don't have unification. You start to define,
But you know, the first definition strikes me as kind of like relatively sort of obvious. I mean, if you have different systems, you have different descriptions. I mean, there's nothing sort of mysterious. I mean,
yeah,
it's kind of like there's nothing novel in this.
nothing like.
So I don't know. It's just
There's no magic of it. Well, let's go back.
This kind of duality, though, the first definition, it's rare, right? It's very rare that you find dualities in physical systems. It's not like that duality is generic. That's might be the important point with the perspective one. When you find them, they're very unusual in the space of theories.
And unexpected.
Yeah.
Yeah. Definition wouldn't be unexpected. Yeah, you find some connection and you just go to one and say, hey, this is the language that defines the other, and that's it. You just killed one of them.
I mean, technically, you could have derived AdS CFT many years ago without learning about D-branes. There would have been enough information probably to put the pieces together, maybe. But, you know, that was the way that historically we found it, by staring at near-horizon properties of branes. Igor Klebanov had done a lot of work with various collaborators looking at the near-horizon properties of black spacetimes like black holes.
Without string theory.
They'd found hints, within the perspective of string theory, yes.
With hints.
And found hints of this duality, and but it's Madison was the one who discovered it and is credited with the find.
Yeah, so again, probably talking about too many dualities is confusing because there are major differences here. But in the case of the classical electromagnetic dualities, that's where unification worked, because you created the F mu nu that put all these two into one tensor, and from that you kind of infer the meaning of E and B when you, of the previous original model. And everything which was in this E theory or B theory it can be inferred through this strong deduction or reduction from the F mu nu. There is no left. I mean, if you are good, then you believe that there is a theory of light which is not captured by electromagnetism. Obviously, physicists don't believe that there is any kind of leftover mystic light.
Well, we hope there isn't, because then we'd be out of a job.
But you can, yes. But that's an exemplar case. I don't. So if the duality is not exact or not complete, everything we said, right, they fall apart. there are parts of this dictionary who are not translatable, and pieces here incomplete dictionary, and
I was wondering about the relationship between duality and conventionalism. So take something like Poincaré's conventionalism about geometry. For example, gives us, again, we put a flat disk in Euclidean space, but it's got some sort of universal force field. So if you live on the disk, you might infer that the geometry of your world is hyperbolic. So what's interesting there is that, well, Poincaré is going to say, well, maybe there's no fact of the matter, you can pick which one you like, but they're in conflict. Either the world is hyperbolic or it's embedded in Euclidean space. It seems that those can't exist together. I mean, it's the idea of duality is that you've got two descriptions which can be and are both true at the same time. Would that be a way of thinking about it?
In the Poincaré case, obviously you want to resist the temptation to talk about that duality in terms of verification, obviously. And that would be a conventional duality, and you want to say none of them are actually right? So you need something completely external from this original theory and these assumptions that will clarify what kind of world you're living. So it is the case of underdetermination, right? So I would resist putting that kind of duality into the context of unification, because in that case, you're right, you don't want to try to look for a theory that will unify the two, the force or the Euclidean plus force or the hyperbolic space, right? You resist to do that. So, like I said, unification is not like universal Swiss Army knife. Have to resist. There are spurious of unification. You can come up with examples. The phlogiston is a spurious of unification. Is that right? They thought that there were many phenomena in phlogiston unified, but they're actually still different. So there is a disunification from cases, right, in history of science. Probably genetics is a good example. We can talk. In what sense genetics disunified? What different stages of genetics create disunification? When you slice off different things of genetics and you say it's evolution, right? And then you obviously see reunify them, but yeah. Stanford talks about this.
Okay, so that's all. So